So I'm Damon Edwards, and that's John Willis.
I'm John Willis.
So we, just by nature of our work, DTO Solutions, John at Docker, we see a lot of companies, high performers, low performers, everybody in between, big enterprises, high-flying startups. So Gene asked us to talk about common threads, things we see people, the high performers, doing.
And so Damon and I don't know, 7 years ago, we used to have all these conversations about this stuff, and we start recording it. So for about 7 years now, we've been doing this DevOps Cafe podcast series.
Yeah, and you can get on iTunes. We talk to people we find interesting, but people who let's kind of long-form style interviews about all things DevOps, transformations, try to dig into what makes people tick. So talking about high performance, I'm sure you've all seen these State of the DevOps report. There's new numbers now in 2016, but you know, something really interesting is, well, first of all, it's just this amazing tale, right? You've got 30 times more frequent deploys, 200 times faster lead times, faster mean time to recovery. Even got some business statistics here. So it's fascinating because people they're doing it faster, they've got higher quality, and they're more effective. And the data is pretty clear about that. But of course, this flies in the face of this conventional wisdom, right? I mean, we've always known that, this is kind of these iron triangles, right? You can have it fast, you can have it good, you can have it cheap, but you definitely can't have all three. You've got to pick two, right? And the crazy thing is this data is showing that that's not true, right? That this triangle has been busted. So, the conversation's been for a while, faster, better, and cheaper. Is that even possible? And I think the data has shown that that is possible. People are achieving that. So I think the question that we want to focus on now is how. How are these companies achieving this high performance? How are they doing it faster, better, and cheaper? That's you.
Oh, yeah. I'm tired. I just flew in this morning. So at the first DevOps Days in the U.S. was an amazing event, and me and Damon did a podcast after that. We normally we interview people, but this one we just wanted to talk about it. And we kind of accidentally created this acronym just by trying to summarize what that event was all about. So kind of a checklist, culture, automation, measurement, and sharing. It's been used as a loose taxonomy for DevOps for about 5 or 6 years now.
Yeah, so when Gene asked us to talk about how are these companies breaking this triangle, how are they doing it better, faster, and cheaper, we said, well, let's come up with another checklist, right? To say, hey, are we thinking about what are the different aspects that we see people focusing on? So I'm going to talk about a few, John's going to talk about a few, and then we're going to get off the stage. So the first one, an org structure that stays out of the way. Focus on redefining, kind of wiping the slate clean and saying, how are we designing the conditions of our organization to go better, faster, and cheaper? And I think the first point of this is thinking about that silos, siloed organizations, functional silos are really the enemy of throughput and stability. And that we have this idea of, well, it makes business sense, right? Well, we're going to group like with like as we grow. We're going to put the planning stuff together, the dev stuff together, the release people together, the ops together, QA, we find it cheaper offshore, so we're going to put that over there. We're going to build these functional silos because that makes good sense, right? Well, the reality is we know by now is that these silos, people are working out of context of each other, they start enforcing more inward, and these walls build up between them, right? And then the handoffs become more and more difficult. The application knowledge, right, starts very heavy in the development. By the time it gets to operations, you just got a bunch of tickets, you're not sure what's going on. Operational knowledge, super deep in operations, but now you've got folks way 5 steps ahead in development. They really don't know what production's even going to be looking like or what the conditions are that they have to deal with. And the business intent, which is huge in planning, by the time, again, it gets down to operations, bunch of tickets, you've lost all context. And this forces are pulling these organizations apart, right? On one side, you've got all this ownership. They can decide what has to happen, but they have no accountability to run it. And then, of course, on the other side, you got all the accountability to run it, but you can't change anything. You're like the abused partner in the relationship. You just got to take whatever they give you. So this is natural forces to just pull these organizations apart and actually make it far more expensive, far more inefficient. Throughput goes down, stability goes down, and the costs actually go up, even though they're supposedly optimizing for cost and quality. So you see what organizations are doing to change this. They're thinking about, well, instead of having these functional silos, how can we build these cross-functional service-aligned teams? Meaning that how can I put everybody together who needs to deliver and run, right? So it's the full life cycle for these particular services and align it towards some type of customer identifiable service. So it's kind of one value stream, one team, with the notion of we're going to get rid of the handoffs and we're going to make things as smooth as possible. Of course, well, hey, we can't do that. We're a huge bank. We can't give everybody their own data center. We can't give everybody their own security team. We can't give everybody their own monitoring infrastructure. So we see them building these instead of saying these functional silos, they're really internal service providers that are providing operational capabilities as a service through these pull-based interfaces. So kind of a redesign and rethinking of the org structure is a strong trend we see with the high performers. Next one up here, they're building everything through an SDLC, right? So everybody knows, CI loops. It's the common way to do things now on the application side. I check my application code into a repo, a CI server, spits out some packages, got a package repo, do some distribution, do some automation to deploy my code. I can do it through an automatic trigger, or I can do it on demand. It's kind of the way things are, right? But think about the high performers. They want that same discipline. So here, infrastructure as code. It's not just. That's not the key part. The key part is infrastructure through an SDLC, right? They're using the same discipline to say we want to everything from our app code, our environment specifications, our runbooks. Everything goes through this same SDLC process, and that becomes the point of collaboration. The specifications in the source repository is how development and operations actually communicates, because their work is going through this same, everything's got a build process, everything's got a packaging point, everything's got a distribution. Might be different tools, but they're all kind of running through this same mental philosophy. And the same people, you only have kind of two ways to interact with the system. One is through the source repository, two is through these procedures that go that way.
And it should be clear, I'm sure people talked about this yesterday, but 2 points. I saw the last presentation, automate everything, right? But then the other thing is everything starts in source control.
Right.
And that's the big change, right? Whether it's a script, it's a config file, source, everything starts from that.
Yeah, and I'd say far more important than more important than the choice of automation is the idea that we're putting SDLC discipline. So kind of the software delivery lifecycle or software development lifecycle, it's a service delivery lifecycle, right? Everything is going through an SDLC discipline. It doesn't matter if it's shell scripts or the latest greatest automation tool. It's getting that discipline as an organization. So, and the third one here is the notion of making the work visible, right? So, you see one of the key, most stark differences between high performers and low performers is the ability to, the work that they do, the flow of information and artifacts through the organization is visible, right? And it's often the idea that there's a shared visibility across the organization. So, folks in development on the operations side, they're aware of what the factory floor looks like. And in low-performing organizations, again, that kind of functional siloed point of view, all they really see is what's going on in their corner of the world. They might have seen a PowerPoint, they might have an idea what happened somewhere else, but no one can really tell you what actually happens. How does actually things go from a requirement all the way through to when they're running in production? What is the actual step-by-step life cycle there? So you see that the high performers do this job of making that work visible. This is actually a value stream map that this is actually in the cookbook, right? Or the handbook, sorry. And the notion is, do you have this point of view? Do you have that supply chain, factory floor point of view in your organization? And what's the point of it? Number one, it builds alignment and consensus across team boundaries, right? So if we're having a problem, say I'm on the ops side, John's on the dev side. From the ops side, I might say, well, developers keep giving me broken stuff, and obviously from the development side, John's like, well, you keep breaking stuff. Right? But why does that happen? Is it, well, because I'm not providing the development side with the production-like environments to test against, or maybe from the development side, they're giving me this, 900 parameter configuration file when only 2 ever change per release. All these different issues that that come along that only really can be solved if that end-to-end life cycle is visible, right? And that helps organizations empower the people who do the work to find the problems and fix the work.
And the key point here too is most times that when you go into an organization, and Damon does this a lot, but you go in and they think the organization is the org chart, yeah. Right? So they see that, and when you show them the value stream, it's so enlightening because it is cross-functional. There is no kind of boundary. You basically see the work as it flows.
Yeah, and it becomes an important part for actually transforming the organizations. We talked about those organizations that, that they went from a functionally aligned organization to more of the horizontally aligned, service delivery aligned organization. What make that possible is they first understand the flow of work and then mold the organization around the flow of work. Rather than the traditional, I'm going to start by defining this org structure, and then I'm going to try to stuff the work into that org structure, and that's where you get that functional silos, that's where you get the bad handoffs, that's where things break. Sounds great on paper, when it actually translates down to the work level, it creates chaos in the work.
And I got to tell you a story. So Damon does this a lot, where they go in, they do value stream mapping, they do a couple of day workshop, and they'll take a whole board and they'll just sticky the whole board and fill out the flow. And he tells this great story where the C-level person who brought him in came in after the second day and looks at the board, and I'm going to do a little color commentary, but there's a whole lot of stupid up there. So
But in his defense, he said he probably has his name on most of it. That was his choice. So, and really the visibility becomes the heart of, we see the high-performing organizations, they have a continuous improvement system. Now some, they just kind of do it reflexively because it's been part of their culture. Other organizations where it hasn't been part of their culture, they have to be a lot more prescriptive and actually build an official continuous improvement system in their organization. But the idea just being, hey, do we have a way to constantly get a shared perspective on what it is that we're actually doing, right? Do we have an actual way to identify what we're going to go work on and go and fixing those things? Do we have the right improvement metrics to actually look at the end-to-end system and say, are we improving how we deliver? And do we have the right visibility and oversight so the executives can actually steer how the work is happening, not just try to steer the org chart, and looking at that sort of for each value stream in the organization. Again, some folks can do it naturally. You talk to the guys at Netflix, it's just like, well, this is how we've always done it. We get together every once in a while, figure out what needs to change, we change it, and we go on our merry way. But everything else in the organization is built around giving that visibility so they have that shared understanding and they can drive it. Other large, more functionally siloed organizations needs to become more of a specific improvement system that they put into place, all towards the idea of, do we have those hooks, do we have the visibility to drive the continuous improvement around how we work, right? We've got a lot, Johnson, we've got the org charts, we've got the application architecture, but are we looking at actually the factory? Are we looking at how we deliver, how we work, and do we have the right tools in place to constantly look at that and constantly be improving that? And in talking about transformation, the organizations that can do that, actually, they fix themselves. There's enough brain power in all of your organizations to fix the organization. The point is, how do you harness that? How do you get all that aligned? And just by saying, go fix stuff, or we're going to start small in all these different places, if you don't have the improvement system into place to harness all that and keep it aligned towards improving the end-to-end system, you get a lot of little localized optimizations, which people think they're fixing things, but they're fixing it in their silo. It makes the whole end-to-end system actually slower or worse. People get frustrated. They're like, see, I knew we could never change. They give up, blah, 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 blah. So, John, you're up.
I'm up. So around 2011, 2012, I think the first article was Keith Morris at ThoughtWorks wrote a Immutable Servers article. And then Netflix then wrote an article about building infrastructure with Legos. And the idea was, that, the Netflix one was, well, the Keith Morris one was like, imagine you could beat your server up with a bat, right? But the Netflix one was describing how instead of using kind of application jar files as your delivery mechanism, what if you could actually create Amazon AMIs, machine images, as your immutable artifact? And so what they did is they actually kind of built their AMIs, stored them in a repository, an artifact repository, and at delivery time, basically delivered immutable servers. Now, caveat is there is no such thing as an immutable server. Once you power on a machine, it's not immutable by definition. But as a pattern, it was immutable in that you never change it. You don't change files, you don't change systems, you don't update it. And literally, you just kind of roll and replace. There's a meta layer that you connect things, but in general, you don't change any infrastructure. So that became reasonably popular as a delivery mechanism. And then a couple of years ago, containers got really interesting. Right? And we started seeing this pattern of what I coined as immutable delivery. And so instead of starting at the kind of artifact from the software repository as immutable delivery infrastructure, we're seeing developers now create immutable artifacts on their desktop. Because the idea now is, particularly in a service-oriented architecture of microservices, which we'll talk about in a few minutes, literally a developer can build the whole construct of everything that's needed for that delivery. The operating system, any potential middleware, and the app all in a binary container. And if they need to test that container in a service architecture, they could literally pull from the artifact repository the other services that they're going to test on their laptop. When they're done with that, they push it down the line, and it goes into a test, acceptance test, automated testing, right? And then again, that process is then immutable. All the other artifacts by other teams and that developer's artifact. And then when it goes into production, again, it's immutable. So it's immutable all the way through the process. And so, Werner Vogels, the CTO of Amazon, says you build it, you own it. One of the patterns of DevOps early on is developers wear pagers. So imagine that the binary that you tested on your laptop is bit for bit the binary that you have in production. And the thing about binary containers or container images, they don't care where they live, like bare metal, Amazon, GCE. Yes. Yeah. So about a year and a half ago, I ran into Josh Corman. We started. The thing about immutable delivery was it's reasonably dangerous for a lot of reasons. It's kind of a black box to the thing. And Josh told me about this book that I'm a big Deming and Toyota Production Systems fan, but I missed this one. But the Toyota supply chain. And there's this concept of the 4 V's and learning. It's called 4VL. And basically, this pattern by Toyota, which was extremely successful for their supply chain, marries really well with immutable delivery. And so, for example, the variety, the first V, if you have immutable delivery, and so you marry that with containers, right? So Docker happens to be my favorite one, but yeah, pick your poison. But containers instantiate in like 400 or 500 milliseconds. VMs instantiate in 2 minutes. To build a cluster or a service structure of multiple containers, a second, 2 seconds to converge that. On a good day, to converge a virtual image stack, 8, 9 minutes, 10 minutes, right? So you get this this kind of speed, and then so in the variability, you get to learn fast. Developers don't have these kind of 15-minute context switches. They're actually iterating really fast. Me and Damon had done a podcast at one point, and we've talked, actually a couple of podcasts where we talked to kind of developer managers. And early on in the Docker experience, they'd say their developers get furious if they can't like rebuild and converge their service structure in 3 seconds. Right, so you start getting this learning fast at the developer stage. At the integration stage, you can build these like crazy horizontal scale tests. There was an early story of like a Postgres table state with Docker where they actually test the state of that table 1,000 times. With VMs, that could be like 5 or 6 days. So basically, you turn kind of days and weeks into minutes and hours. And then in production, the ability to iterate a cluster happens in seconds, right? So you have this kind of variability, all the things that we've learned from like lean startup, lean enterprise, build, measure, learn, learning fast. And then on the velocity, like I already kind of described that. This idea that you can literally build service structures in seconds. You can roll fast. So the velocity is kind of inherent with immutable delivery. So one of the things I do want to point out is there's, if you take containers and immutable delivery, there's a perfect marriage there, right? Because containers just fit really well with this immutable delivery pattern. And in fact, a lot of people have picked up on this pattern since containers become popular in the last 2 years. Variability is my favorite V because in the old days, basically the way people built infrastructure was checklist, manual, right? And the variability of your infrastructure at every stage was chaos. You'd be testing software on your laptop, and then it went into kind of integration testing, was a completely different infrastructure, and it went into production, it was completely different, right? And so then about 2006 or 7, Puppet became very popular. CF Engine had been around for quite a while, but it really wasn't that popular. And people started adopting this infrastructure as code model. Way better than the checklist. Decreased variability. Right? I can infrastructure code my laptop. I can infrastructure my code my integration. I can infrastructure as code my production environment. Great. But guess what? There's a level, and I would say at scale, a significant level of variability there as well. Because by the way, infrastructure as code is kind of it's a script build. It's not immutable. So what you build here, whether the package repository is available, if a silent script dies, there's a great paper on this. It's called Why Order Matters, right? And so the beauty of immutability is that variability goes away. There is no variance. I mean, there's some host, you have host and then you have containers on the host. I'm not saying there's zero variance, but in general, you have a binary, and that binary is basically immutable. So you really decrease the variability. And at scale, when you add that with speed and variety, you get this speed. And we're seeing this now. We're seeing companies that are adopting these things and be able to deliver a software at an incredible pace. The last one is visibility, and that ties into very well to kind of microservices, which will be kind of the next topic, which is that I'm not talking about like a GUI that shows the delivery. It's about bounded context. You're building services that are kind of domain driven. They're smaller pieces. It's easy for you to kind of grok the architecture and the visibility of what's delivered and what is actually running in your infrastructure. In fact, one of the big things about that I loved about this Toyota supply chain is that it really expresses ideas of bill of material, things like that. So when you have immutable delivery, the danger is, what is all that black box stuff running in production? If you follow the kind of 4VL, you basically do things like you build a material, you define provenance, you do all those things all the way to line, and you have this really good visibility. So imagine you can like restart a cluster in 3 seconds, and you've basically tagged all the bounded services that are running in these immutable infrastructures, and you have kind of a zero-day attack, and you need to basically fix that immediately. So you can roll a cluster in basically now you know where everything is, and you can roll a cluster in a couple seconds.
I think the key point here is that of all this, right, if you've probably gathered by now, it's not just doing the same thing faster or doing the same thing a little more reliably, but fundamentally these things build up for organizations to change how they do business, change how they function and deliver as an organization. It's pretty revolutionary.
And then microservices. Next slide. Next slide, sir.
Sorry, you got it.
So Microsoft, I'm sure most people know this by now. There's 2 good definitions, in my opinion. There's probably a lot more. But Sam Newman, who wrote the book, O'Reilly Microservices book, Small Autonomous Services That Work Together. My favorite is Adrian Krakoff's. Almost everything Adrian says is my favorite. But he says it's loosely coupled services-oriented architectures with bounded context. Right? So again, idea is loosely coupled and bounded context. The thing is, there's a really cool convergence that has happened within the last couple of years. We went from kind of SOA to kind of Eric Evans' domain-driven design to 12-factor apps from Heroku, and now we got microservices. So we got this idea that we've loosely coupled bounded service that we develop. Same time, containers come in and fit really well. People ask me, do you have to, does Docker have to have microservices? Does microservice have to have Docker? The answer is no. But they converge really well. And then if you add this kind of small 2-pizza team, which is kind of a lean idea that we've adopted, you have this nice little thing that you got small teams, you kind of have bounded context or microservice delivery, and you can build immutable kind of service artifacts. Next slide. So I joked to Damon, like, the world would be really boring if we didn't get to steal Adrian Krakoff's slides periodically. So anyway, so the idea is microservice is kind of is the opposite of kind of monolithic services. So your classic monolith, right? Like if you're delivering a release plan, you basically have to have some coordination, right? Give the next slide if you don't mind. So like, as you're coordinating, you got to coordinate. If there's bugs, so there's a lot of kind of inertia around a monolith. Now, some companies do it really well, but it's really hard. Like they pay their dues. Like Etsy has a monolith, Facebook is a monolith, but they work really hard to do that well.
And I think the idea is the transactional overhead, right? So the process of that integration, the testing, the discipline has to go in there. Everything you have to build to try to grease this process, because you have these natural bottlenecks, because you have this natural friction that has to happen, both friction in the communication in the organization, friction with dependencies at the application level. You got all these long rework loops, right? We don't find bugs till they're integrated later, or then we find bugs till it's integrated later again in production, drives this rework through it. And the idea is it just adds friction to the entire life cycle, and you have to spend a lot of effort then to try to decrease that friction, constantly fighting to decrease that friction, and that eats up a lot of the capacity and value that time that can be going to value-add activities in your organization. John said some people do it great, but think about all the effort that has to go into greasing that pipeline to get things through.
Yeah, the unicorns are awesome at it, right? The horses are kind of going to be better off with this kind of microservice architecture. And the beauty of microservices, you go back to Adrian's definition, right? Loosely coupled, bounded, and then you have this parallelism on delivery. And so there's other side effects too, right? Like notice that some of the services are PHP, Node, Python, like that doesn't get in your way. You get to make these bounded decisions for the delivery. You get the speed. You can parallelize the delivery. So by nature of this delivery model, smaller teams, and again, immutable infrastructure and less inertia of how you have to deal with a monolith from delivery.
Do you want to talk about databases?
And then the Microsoft, the Amazon has this great presentation where they talk about this kind of distributed database, where there's no central database. So there's even a kind of a microservices architecture for data delivery. And then finally, so the whole idea is, Damon went through kind of org structure of high-performing organizations, SDLC, important, making work visible, value stream mapping. I think immutable delivery, container, small teams, immutable delivery, microservices is the way to get a competitive advantage. We save the best for last, which is respect for people. So next slide. So here's the thing, right? We never really set out to define DevOps by CAMs, and I'm going to say this, and I'm not trying to create a new definition for DevOps, but I think I think a lot about DevOps is, if I had to create a definition today, I'd say it are patterns that turn human capital into high-performing organizations. Right? Because it's all about the capital. If we've learned anything from Toyota, if we've learned anything from Lean, if we've learned anything from all the presentations of the brilliant people that Gene has gotten together, we basically understand that it is how we collaborate and how we work together as humans. The tools are secondary. Right? So the high performers care about their people. And so the high performers embrace diversity. Etsy uses it as a competitive advantage. High performers understand empathy. Things like embedded ops into dev into ops, C-level people having to check in code, C-level people having to show up at hackathons, board members coming and check code, companies that rotate people. It's all about empathy hacks, right? And then finally, the area I've been very passionate about over the last couple of years is this concept of, burnout. So originally, I started presenting about burnout because a young gentleman committed suicide in the Los Angeles DevOps community about 1.5 years ago. I started talking about it. I started doing research. And what was interesting is I got to meet this woman, Christina Maslach, is she is the
Berkeley.
Foremost authority on occupational burnout. She's a PhD professor at Stanford.
Berkeley.
And what?
Berkeley.
No, Stanford.
Oh, Stanford.
You're to Stanford.
Sorry.
I'm from Atlanta.
I'll be back here.
Sorry. He's from San Francisco. But she's identified this concept of the kind of workload balance scale. These what they call the 6 mismatches. the idea is that so the kind of clinically defined burnout can occur when an organization and these 6 mismatches occur. And what's interesting is it's about the system, right? And so, overwork, overload, right? Those are classic. Death marches are not cool. Lack of control, like we kind of embrace intent models. But rewards and fairness, right? There's a balance there, right? In some organizations, the idea, come on, give me 2 more minutes.
30 more seconds.
In some organizations, the concept of fairness, like salespeople might be the highest paid people in an organization. For you, that might be okay. For somebody else, that's not okay. The point here is, when I was doing this research, I realized that these clinical definitions of the mismatches of an organization people are the anti-patterns of DevOps. And so Christina Maslach says in some of her presentations that she goes into a corporation and she says to she wants to help them with burnout, and the common response she gets is, "I'm not running a country club. Like, what, should we get couches for everybody?" And I thought about, like, what if we could flip this, like, the inverse of that. If we were able to understand how to treat our people in this kind of way, what if we could turn that into optimization? And what if we could sell C-level people about not only doing the humane thing for our people, but actually use it as a competitive advantage?
So that's our presentation. And so John and I are going to be over at the unconference tables after this. If you guys want to talk about any of these things, I know it was kind of a fast survey course. Please do. Also, you can contact us directly. Please follow me on Twitter, because John is way ahead of me in the Twitter follower count and lords it over me. And our podcast, DevOps Cafe, and buy the book. Right.
Awesome.
Thank you very much.
Thank you so much, guys.
Done.
And thanks, guys.